Good morning, everybody. Thank you so much for being here, and I'm very thrilled that we can participate in this panel. My name is Coco Jervis. I am the program director at the National Women's Health Network. For those of you who don't know, the network challenges dangerous drugs and devices and works to ensure that women have full and complete information about all the products that are used and marketed to them. I'm just going to serve as the chair for this phenomenal panel. We have 4 excellent and knowledgeable speakers. We only have an hour for presentation time, and then we're going to open it up for questions. So we want to quickly run through this. And because of that, I'm not going to go through the bios that are in the packets already, but I want to highlight that we're not going to only hear about factors to evaluate what is a good research study. We're also going to hear about information related to patient privacy and open research data, determining the data sources for use for intervention effectiveness research, and then we're going to end with a really interesting discussion about the legal requirements versus, I suppose, the practical application of research prevented on clinicaltrials.gov. So without further ado, I would like to introduce Stephen Goodman, who is the Associate Dean of Clinical and Translational Research and a professor at the Stanford School of Medicine. He's the Chief Division of Epidemiology and Health Research and Policy and co-founder of the Meta Research Innovation Center at Stanford.
Thank you. It's really, really great to be here this morning. I have to say, I had no idea whether this would be an audience of 30 or 300. I pictured the 300. I much prefer this. I like you being close. For me, it's 6 a.m. in the morning, so if I slur my words and I seem a little slow, that's the explanation. I won't tell you what time I woke up. So this title slide is actually, you could tell what talk I adapted for this. This was my life before I came to Stanford at Johns Hopkins, but let's just get into this. So I was assigned the literally impossible task of talking about what makes a good study in 12 minutes. So it's hard, and also my views on this have changed over the years. When I was young and idealistic and naive, I could give you a list of all the characteristics of what made a really, really good study. But then, you get older and life happens. It's sort of like at the beginning, when you're young, you could list what are the characteristics of a good partner, a good boyfriend. And then you get older, and then you basically learn what makes a bad partner. And then you realize that, if somebody doesn't have any of those characteristics, that's actually pretty good. In fact, that's great. So that's how I've changed. There's no such thing as really a good study in the sense that it's perfect. But if you could avoid a lot of pitfalls, that's really good. In fact, it's great. These are the results of what may or may not have been good studies, and this is presumably why we're here. These are things identified as cancer risks: electric razors, broken arms, but only in women, fluorescent lights, allergies, breeding reindeer, being a waiter, owning a pet bird, hot dogs, being short, being tall, and if you've missed any of those categories, having a refrigerator. So maybe those came from bad studies, I'm not sure. This is a BBC coverage of a study from 2002, stress not linked to breast cancer relapse. Okay, good. 2003, stress raises breast cancer risk. 2005, daily stress stops breast cancer. Okay, we're actually going to look into these studies in a minute. And there's actually another article, it goes on, that's saying that hearing about breast cancer risks is a risk itself. So now I put you all at risk. In my search for these, actually I've used those before, but online last night I found this that just appeared. It says literally 1 hour ago, it just came out last night. This actually looks like a pretty good study. It's about bisphosphonates as an adjunctive to standard chemotherapy, and maybe I'll talk about that. This actually looks quite plausible. So let me start with saying conclusions are not, this is why it's so difficult to talk about good and bad studies. It sounds very binary. But conclusions are not, at the end of the day, false or true. What we have is, all shades of gray. You go from a claim being false to it being almost certainly true, and everything exists in the middle based on what the prior evidence is, the quality of the design, the quality of the execution, the strength of the studies, And of course, do we have any explanation for it? And figuring out where you are in these shades of gray is really both the art and the science of figuring out what a study tells us. And a better question is, what does this study tell you? And how far does it move you? Not, is it good or bad? That binary label is really not very helpful and doesn't get us very far. So these are the key study characteristics that I always think about, and we'll drill down just into two of them, although I think this group already knows much of this stuff. So first we start with the question, then there's the issue of the strength of the design, the strength of the conduct, the strength of the analysis, the strength of the interpretation, and what is actually recommended at the end of the day. And you can look at any study through this prism, and again, I'm going to focus mainly on the question because I think that sometimes doesn't get its due. I'm going to teach all of design in 1 minute here, but you all are together in this room because in some ways you understand this. The evidence-based recommendations are based on an implicit model of what are stronger designs and what are weaker designs. So I'm going to I have resisted the temptation to go too far into this, but one of the key distinctions is it an experimental study or an observational study? An experimental meaning that the researchers have manipulated some sort of exposure or intervention, that is through randomization. There has been a decision about who gets what, and that's to eliminate or minimize the effect of other factors that make people choose one therapy over another, and that if they do that, then it's an observational study where exposure to a risk factor or whether you get an intervention is just you study it as it occurs in the real world. And that introduces the possibility that maybe other things about those people are different. So the RCT is we have our source population, we randomize to one therapy, we randomize to another, and then we compare those groups. It's in theory a very easy, a simple conceptual design. It's actually very powerful theory behind it, and we rarely approach that. Cohort designs, we start with two groups of people who are different in some way. It could be that some got an intervention, were exposed to something, the other were not, and then we follow them forward in time. So we follow them forward from the cause to the effect, and we can do this based on data we already have in hand, which it would be non-concurrent, that is, we look at data that was gathered in the past to the current day, or we could start today and follow them forward. Case-controlled designs go in the opposite direction. We start with people who experience the outcome, the disease that we're studying, and those people who didn't have the disease or didn't have the outcome, and we say, how are these people different? And so we go backwards in time, in causal time. So this is all of design in one slide. This is a PhD in one slide. So here, this is the only one I'm going to spend a little time on. Does this have a little arrow or something? No. Okay, maybe here. There we go. So here we have the true effect in the study setting. This might be what we actually observe, and this might be the actual effect in the field. So why are these three things so different? Okay? So this is what we see in the study. It may be different in the field because life is different out in the real world. Treatments aren't given the same way, patients aren't the same. That goes to this issue of generalizability. What about if the average effect measured by the study is actually different than the true effect? That's a function of bias. That is, the study is sort of, we call it fundamentally flawed in some way. That is, the populations are different from each other in some way other than the intervention or the exposure. And finally, there is random error down here. And what we really want is for all these arrows to be lined up. We want the effect in practice to be the same as the effect in the study, to be very, very narrowly variable because of random error. So we reduce random error by having a large sample size. We reduce bias by having randomization or by having very, very good statistical methods to eliminate bias. And we make things generalizable by making the samples that we study as representative as possible, or maybe even best, doing the studies in the communities that we're interested in. So if we can have representative samples, unbiased studies, large sample sizes, then everything lines up. And almost every critique of a study is going to go to one of these three pieces. So as I say, in a complete course in design in one slide. So we want this arrow over here to align with that. And it's very hard both to do that and sometimes to assess it. So it's exactly that sort of considerations that lead to this, what we call a ladder of evidential strength. And probably all of you have seen something like this. And they vary a little, but at the top you have meta-analysis of individual patient data, large RCTs as you go down, smaller RCTs, and then you get various kinds of observational studies. And the most important thing here is that these vary. This is actually on this strength of evidence scale here, and you can have a situation where a small RCT might be better than a large one poorly done, or an observational study is actually better than a small randomized controlled trial. So there's a lot of latitude and a lot of judgment. This isn't a strict hierarchy, and again, that's part of the art as well as the science. So one of the first things I do when I teach is, I have people identify what's the design. It's actually sometimes very, very hard, even knowing what the design is. So this will show you how hard it is. So say, what's the design? So this is a form of in vitro fertilization, and they're trying to look forward and seeing are there health effects on the babies that are born through this particular technique. It says, a retrospective case control study of developmental and other outcomes by children born with this therapy. Okay, so you say, what's the design? Oh, it's a case control study, right? Okay, you look at the abstract. Okay, there it says, right there. Let's see if I have there. Retrospective case control study. So how could that not be the design? So here we have patients, 58 singleton children born after this, and 38 normally conceived singleton children, and they followed them forward to look at their health outcomes. What kind of design is that? That's a cohort design. You start with the kids at risk, and they're not at risk, you follow them forward. Why did they call it a case control design? Because they had cases and they had controls. So this shows you a lot of folks in the field, including the investigators and the journal editors, got it wrong and put it in the title. So you really do have to think about this, and you see this all the time. Now, what's the question? Now, a properly configured question, it has 5 parts, and you will see in almost every study, the reason that studies are different is because they're fundamentally asking the different questions, not the wrong questions, often the wrong questions, but different questions, and it's not recognized. So we'll go through this exercise with those 2 studies that I showed you at the beginning. So in a properly focused study question specifies the patients, the intervention, the comparison, the outcomes and the other measurements, the timing, and the setting. This is the famous, well-known PICOTS, P-I-C-O-T-S framework. Okay? So we're going to look at those studies through this prism, and in most debates about things, it always comes down, if you say this at the beginning, you'll sound so smart. You say, well, they're asking a different question. It's almost always true. But you only find that out. They never say it in the title. They don't say it in the conclusions. It's really hard to find. You have to dig deep into the methods to figure out what question are they really asking, because they always want to be asking a different question than they actually did. So let's go back to those 2 breast cancer studies, one of which said that stress is a risk factor for breast cancer, and the other says that stress is a preventive. So in the first one, it was the patient population. We're going to go through the structure. Healthy Swedish women between the ages of 38 to 60 was a representative sample in 1968. What is the intervention or exposure? So here the exposure is to stress. Okay, so their definition, and I'll show you in more detail in a second, that they were stressed for more than 1 month in the 5 years before 1968. They were asked at a single point in 1968 a series of questions. I'll show you what they were. The comparison exposure is that they were not stressed. They did not have that greater than 1 month of stress. The outcome and the measurements, the outcome was, did they develop breast cancer in the succeeding 24 years? And they looked at other things like family history of cancer, BMI, education parity, and other risk factors. The timing, they looked at the exposure once, that is stress once, and then they followed them for 24 years, and the setting, it was population-based. Okay. Now this is the questionnaire on stress. Don't laugh. Have you experienced any period of stress? And with stress, we mean you have been irritable, tense, nervous, anxious, afraid, anguish, or sleepless. for 1 month in the past 5 years, connected with your concern for work, health, family, conflict with people around you. Now, honestly, how many people haven't experienced that? And then this is what you check. Never experienced mental stress. This is a sign of some derangement, I think. Occasionally experienced mental stress. So if you were in these boxes, you were in the not stress box. And then if you answered any of these, you were in the high stress box. Anything beyond occasionally experienced mental stress during the last 5 years. Now, Sweden, maybe they don't have much stress there. I'm not sure. I don't know Sweden in the 60s. But that was the exposure. If you don't go and look at this, everybody's laughing. You have a lot of intuition about this. You don't have to be trained. You don't know what this study is really asking. And does that headline capture it? Okay. So then the next study. Patients, population, Nordic, so they're vaguely comparable. Healthy Danish women, roughly the same ages. In 1981, a different period of stress maybe. But they were enrolled in the Copenhagen Heart Study. And that turns out to be, even though it's population-based, very important. The intervention or exposure was the frequency and intensity of stress. There was no time frame, not in the past 5 years. Comparison was low, medium, and high stress. Outcome measurements, breast cancer, all those other things, except because this was a heart study, they didn't gather almost any information on breast cancer risk factors, including family history of breast cancer. So that stuff wasn't in here. Okay, so now you see these are really very different studies, both imperfect. Timing, they followed them for 18 years, population-based. So let's look at their definition of stress. They didn't specify the 1 month it was, so they broke it out into level and frequency. Level, no stress, 0. Light was coded as 1. Moderate, 2. High is 3. I'm not sure what those meant. That's literally what they asked. Frequency, rarely, monthly, weekly, daily. And then they added up these two scores. So you see the highest score you could have is a 6. The lowest is a 0. And if you had 5 to 6, which meant you either had high level of stress weekly or moderate level daily, that would get you into the high category. Okay? And they found, so now let's look at the design. Both were cohort designs, right? They started with populations at risk. There were 1,600 women in study 1, about 7,000 in study 2. In study 1, the relative risk was 2, just significant. That is elevated, doubled. But if you look at the absolute risk, and this is another measure, is that the outcome should always be something you care about and understand, and that was 2.5%, going from 2.5% to 5% over 24 years. That's getting breast cancer, not dying from it. And the second was a 40% reduction, a relative risk of 0.6. And the difference between these was attributed to the frequency of stress. That is, it was the impact of having stress every single day. Maybe that was better. Maybe that's good for the immune system, but not having a huge amount of stress for a month. So this is literally what's in all the news. So if you don't burrow this deeply and look at the methods, you don't know what question they asked, and you can't begin to know why things are the way they are. So this is a meta-analysis that just appeared a couple years ago that looked at 116,000 women, and they found no relationship for any cancer, but it was only work stress. So they didn't include any of the other stress. Fundamentally, a different question. I would say probably stress has no effect on anything.
So that means we can all relax.
Yeah. So, and the other message here is, of course, one study never settles anything. I mean, you should always be looking at collection studies. So here's my one-liners on all the rest of the things, because I've already used up my time. The question, is it clear what it is? Does it have all the pieces? And for you in particular, for this group, does it include the evidence elements you care about? Is it on a surrogate endpoint, or is it on a real health outcome that people feel and that people understand? That is it a question that makes a difference to you? And is it clear? The design, the number one question is, what was the design? And then how strong was it? The conduct of the study, the number one thing is, you could give a whole graduate career studying this, but can you simply tell what they did? That's the number one thing. Can you figure out what they did? And if you can't, then it's a black box. The analysis, is it thorough? Is it just described thoroughly? Again, you don't want it to be a black box. Interpretation, Do they have the limitations? Do they incorporate prior evidence, and what does this add? And finally, in terms of recommendations, who does this apply to and what should be done? So the last few words are just on media coverage, because I'm not embarrassed to say that that's how I find out about some studies. I don't read every single journal every week, and this is my favorite medical journal, New York Times. So magnets lessen foot pain of diabetics, a study finds. You notice they put down here a finding that runs counter to many studies. You would think they would be a little bit embarrassed putting in bold type saying that they didn't do their job. That what makes this publishable is exactly what makes it unbelievable. And why didn't the other get the same headline? So these are literal quotes from the article. We have no idea how or why the magnets work, but it's a real breakthrough. And while the study must be regarded as preliminary, the early results were clear and the treatment ought to be put to use immediately. I won't bore you with the Cochrane review a few years later that showed that this was absolutely worthless. So there is this really wonderful site that looks at the coverage in the media. And for those of you who don't know it, put this down. It's healthnewsreview.org. And they go through, I don't know if you can see there, they give from 0 to 5 stars for the quality of coverage. And they have in the media, and they have very good criteria that they apply very systematically to every single news article that they review, and they really do a wonderful job. Here are the criteria that they used. I won't read through them; you can see them, and they include things that you wouldn't that you might use in your own assessment of papers, but often we hear about them through the media. I like, in particular, are the sources independent and conflicts of interest identified? Is it based on a news release? So anyway, just this is the center we have at Stanford. It's has this crazy name, Meta Research Innovation Center at Stanford, but it's really dedicated to figuring out, both studying and figuring out ways to improve the quality of what's published in the research literature. We're having a big conference in November you're all invited to. You can get details on our website. Our web page is actually going to change dramatically in a month. It's sort of simple right now. And I'll end with Dilbert and his commentary on science. He's out on a date with a young woman. She says, "I collect crystals." He goes, "Uh-oh." "But I don't know of any specific evidence that they can heal." And now he's very relieved. He says, "But it's my point of view that they do." His final comment is, "Since when did ignorance become a point of view?" So I know that this organization is all about making sure that ignorance does not become a point of view. So thank you very much for having me.